Hello, my name is Steven Rakelboom. I am partner at The Grain, and in this video I will explain how a manufacturer of dry cooling systems will change the way they do business with their customers completely by the use of AI. Let me introduce the company SPGDC. SPGDC is a manufacturer of ACC's dry cooling systems that take care of the cooling of the steam cycle for power plants. No need to tell you that that device is very important in generating electricity. So operators of power plants need to be able to rely on the performance of the dry cooling. And that is why SPGDC wants to move from just selling dry coolers to selling performance. Now, in order to be able to do that, they need to have a better understanding of how their system works in a variety of circumstances. A boiler is heated by a heat source and generates steam. That steam is then transferred to a turbine that drives a generator, and that generator produces electricity. Of course, the steam needs to be cooled down, and that is done in an A-frame, as you can see on the picture. An A-frame because it's built in the shape of an A, and it's basically a heat exchanger that is cooled down by huge fans that sits beneath them. This is how such an ACC looks in practice. You don't need only just one A-frame or one fan, you need a whole array of it. So a little bit bigger than your household fan, I would say. Now, what we want to achieve is maximizing cooling performance, and the back pressure at the end of the turbine has an enormous impact on that performance. The lower the back pressure, the higher the cooling performance, the more power the power plant can generate. Now, cooling performance is influenced by a number of variables, amongst which is steam flow, the heat loads, but also the ambient temperature. In the graph on the slide, you can see on the y-axis the back pressure and on the x-axis the steam flow for various temperatures. There you can see the relationships between both variables. To get from selling dry cooling systems to selling performance, the first thing you need to do is to provide your customer with a monitor. And that monitor is set up with data that comes from sensors placed on the ACC we explained in the previous slide. So the sensor data gives us information of what is going on exactly at this moment at the ACC, but it also gives information about what the cooling performance is going to be in the future, given the current circumstances, like wind speeds, like temperature. Not only can we predict what the back pressure is going to be or the performance is going to be, we can also give information of what the optimal settings should be to increase the output of the electrical power plant. For instance, the number of fans that are used, we saw that there are a huge number, an array of fans that are used in one cooling system. The number of fans can also have an influence on the cooling performance. Now, how exactly do we do this? So we started by building a theoretical model that grasps the relationship between steam flow and back pressure, and we create a simple model that gives us a theoretical insight in how back pressure relates to steam flow and temperature. And we do that for a number of constellations in numbers of fans that are used. Then we look at historical data, and we look at what the theoretical back pressure should have been and what the actual back pressure really is. And that delta is explained by environmental variables like wind speed, peak cooling, and so on. So by combining artificial intelligence that explains the delta between the theoretical and the actual back pressure, we get a good insight in how such a cooling system performs in situations, even situations we've never seen before. And that is exactly what SPGDC needs to be able to sell performance, cooling performance, rather than cooling systems. Thank you for watching and lots of success with your projects.